All right. All right. So yarn became only for managing the resource, as in managing who will do what or what kind of computation. I mean, which program will be run on what computer, and which computer is free and which one is busy, how much is the load on everyone. So that's the duty of yarn. The workload, whether executing SQL, executing maps and reduces, those kind of works were left to the individual applications. So here you can see that because of yarn, we got the full many components which do the computing for us. All right. Because of abstracting yarn out of MapReduce, there were other new genre of components that came in, new genre of applications that came in and can run on yarn. As a matter of fact, Spark can run on top of yarn, and Spark is fairly good solution. And the other important thing you need to know is you do not need to install these individual application. You just submit these application to Yarn and Yarn will install these applications on the network. Good? All right. Okay. Bring all to the front. All right. Any questions at this point? All right. Just give me a second. Give me a second. I'm trying to install a component which I might require to draw. All right. Narottam's question is, can you do a little recap? So we were doing a little recap. So as we had discussed earlier, then when the data grows bigger, you cannot handle it using one computer. And that's where the HDFS came into play. HDFS helps us to handle the volume. If you have to do the computation on a huge data, you cannot use a single node, single computer cannot do the work. And that's where MapReduce came into play. And then later, and then later, All right.
Muted. Unmuted.
Hi everyone. Are you able to hear me now? Okay. Extremely sorry for again the network problems. All right. All right. Okay. So I was trying to do a quick. Just a second. Just a second. All right. So let me again talk a little bit from the beginning. So to handle big data, as in to store the big data, we talked about for storing we use HDFS, and HDFS essentially store data using many computers known as data nodes and one node for storing metadata called name node. All right. So that's how we solve the problem of storage by distributing data on many computers. Second was for computing. For computing in Hadoop 1.0, we used MapReduce. Okay, MapReduce is a form of computing whereby you provide map function and reduce function. Map function is done on all the nodes distributedly, and the result of map is sorted and given to reduce. That's basically MapReduce, and that's a one form of computation, and almost every kind of computation can be broken down into MapReduce. So the assumption with MapReduce was that every computation can be broken down into MapReduce, but there were certain kind of computation which was very ineffective in MapReduce, and MapReduce was being the only paradigm to work with became very limiting, and that's where the idea of yarn plus applications such as MapReduce came into play. MapReduce, Spark, and there were many other applications that were installed. All right. So again, in Yarn, the computation, or in MapReduce, the computation is distributed on many computers. So effectively, what we will be learning on all of these sessions is how do you solve the problems using many computers. All right. All right, good. Now we have the drawing and we can draw using this tool. All right, so is everybody comfortable so far? Is everybody comfortable so far? All right, any questions? Narottam, did I make sense to you? Great, great. Akash, Akshata, Nandkumar, Ravindra, feel free to ask questions because if you don't ask question, I feel that we are little lagging. Okay, so if you have a question, please ask whenever you get the question because at a later point of time it may not be a good idea to answer. Good. Question from Anil is, can you give an example of non-MapReduce computation? Take a look at this. So MapReduce framework has its own limitations, meaning it was very slow. So it was not very suitable for online processing or real-time processing. Okay, and that's where the Storm, Giraffe, and Spark and AdSpace, Stays, all of these played a very big role making it faster. Okay, for that matter, Spark is actually competing head on with MapReduce. Okay, you can see that. All right, so Yarn was created to support workloads other than MapReduce. Not only MapReduce, but other kinds of workload could be given to the Yarn, such as if you want to run online or real-time processing, then you can use MapReduce. Then is scalability, because we for every new kind of things we cannot keep modifying the platform. Instead, people should be able to install these new applications whenever they want. Next is in Yarn, the MapReduce programs. Since people wrote programs which would run on MapReduce, and there is a certain format in which you have to supply the input to MapReduce framework, and and when Hadoop 2.0 came into play, those programs did not need to be rewritten, which means our old MapReduce programs were still compatible in the new one. This is called backward compatibility. So Yarn provided the backward compatibility so that people so that the code which ran on top of MapReduce remain intact and did not have to be changed to be run on Yarn. Only thing that was required was that people need to recompile MapReduce code. Okay, we will go into what does MapReduce look like, and then we will also go into how does Spark look like, and we'll go into these details. All right. Now, because of Yarn, we since it allows different kind of workloads, there was improved cluster utilization. It provides agility, as in ability to execute different things and ability to manage the resource more effectively. And since MapReduce was batch oriented, we could not use MapReduce for real time, and therefore we needed some real time frameworks and similar new streaming frameworks, and therefore Yarn was created. All right, what we called job tracker in MapReduce 1 became many components in Yarn. Okay, you will see that how big the difference is. Okay, so job tracker became out of job tracker resource manager, application master and timeline server was created. Out of task tracker became node manager, and slot became a container. What was slot in MapReduce 1? The slot means it will be running a program in the slot. Okay, it will be running your logic in the slot. Similarly, that became container. So this was the transformation from MapReduce 1 to the yarn. All right, we will walk through this once. This is very important because I've met quite a few people, and they could not explain how does yarn function. And this is something which I this is my pet question, and this is a pet question to many people to ask about how does yarn function. And what he found is that even if people mug up what is yarn, still they falter in the interview discussions. Okay, so this is an important part because it not only gives an idea on yarn, but it's a general framework how to divide the work across the cluster. All right, so let's try to understand how does it work. Let's say you have four computers in a network. On these three computers, you have installed node managers. So these three nodes have become your node managers, and they will be doing the actual work. One of the computers is denoted as resource manager. Okay, so here till this point, it's fair enough to take the analogy of.
Muted. Unmuted.
All right, looks like this is disconnecting more often than I had thought. Okay, so let me just see if my third internet connection is working fine. The net works whole day perfectly fine, or maybe we are not able to observe that it's not working fine. Let me just check if. All right, let me just check if my third connection is going okay. All right, no, actually, the third connection is also not great. All right, so we basically are trying to understand how does yarn function. Okay, all right, here we go. Okay, so yes. All right, so I'll just keep this open. All right. So we are trying to understand how does YARN function. YARN stands for Hadoop, yet another resource negotiator. So it's made up of largely two set of nodes. One is called resource manager, while rest are called node manager. Okay. Now, there was one term which we used called slot. Slot is basically the smallest unit of execution. The way when we run a program on your computer, we call it a process. In a similar way, if we run something on the Hadoop, earlier we used to call that as a slot, the smallest unit of execution, because here one program executes on many computers, therefore one program basically runs in many slots parallelly in the cluster. Therefore, slot is the smallest unit, not the program or the process. Okay, so similar to slot, question from Ravi is where is node manager located? Node manager is located on every computer. Generally, wherever you install data node, you install node manager. Node manager's role is to get something done on a computer, while resource manager is like prime minister of a country, or you can say president in the countries like US. So here it's a prime minister of a country. The resource manager is a prime minister of a country, and in that country there are small states, and every state has got one chief minister. And in our analogy, a chief minister is node manager. Okay, so if you call the whole cluster as a country, then resource manager is the president or prime minister, the main person of most important person of their country. While okay, and if every node or every node is a state, then node manager is the chief minister of the state. All right. Now, let's understand what's going on. It looks like fairly complicated. The idea is quite simple. As opposed to task tracker and job tracker, here, here you have resource manager and node manager. And smallest unit of execution is a container. Container is like an office inside which some work happens. Container is like a small factory in a state, in a place in which some work happens. All right, now let's try to understand this mechanism. And before that, I'd like to explain two questions. A question from Ajay is number of slots equivalent to the number of processes a node is allowed to run? That's correct. Node is basically, slot is kind of a place of execution. Okay. Samip's question is, so resource manager is located in name node slash job tracker. So resource manager is kind of the job tracker in Hadoop 2.0. Okay, 2.x. And generally, it's not necessary that you install resource manager on the same machine as node manager. Okay. In fact, you should always install node manager on and resource manager on two different machines, because both are memory and computational intensive. So name node and resource manager, although they can run on the same machine, but you should generally install them on two different machines. All right. Akshita's question is slot is inside node manager executing calculations. Does it also fetch data from data node? Yes, that's correct. But that's a very good point. So yes, node manager when it's running the data inside the container, it also allows the container to fetch data from data node. Okay, and the important part is the node manager is generally located alongside with data nodes. So there is a process called node manager running on the machine. At the same time, there is a process which is called the data node and running on the same machine. Okay, so when the node manager fetches data, it generally fetches data from the local node and effectively avoiding lot of network traffic. Okay, a question from Ajay: is there a separate container for each task? Yes. Okay, a question from Akash: can node manager and resource manager be on the same machine? Yes, they can be. Yes, they can be, but I would generally avoid them because resource manager and node manager both consume lot of resource. Therefore, in a heavily running cluster, you should generally keep them separate. Very good questions, very great questions. Keep them coming. Okay, so here is the idea of yarn, and this is how it generally works. Okay, so imagine this ecosystem to be a country, and again, wow, enough. I'm going to switch. All right. Hi everyone. Are you able to hear me now?
Muted.
All right.
Unmuted.
All right. Are you able to hear me now, everyone? Okay. Okay. So again, a disconnection happened, and I've shifted to another connectivity now. Are you able to hear me clearly? Yes. All right. Yes. All right. So, hi everyone. Are you able to hear me clearly? Looks like it's not working, and I'll have to switch back. Hi everyone.
Muted. Unmuted.
All right, all right. I hope I'm clear now. No, everyone are you able to hear me? Wow. Okay, so finally the voice was nobody was able to hear me when I was on my 4G connection. So I'll rather. All right, let me try to answer. Okay, so Nand Kumar, is that your question? Was I able to answer your question, or should I answer again? Hi everyone, are you able to hear me clearly? Yes. Hi Akash, are you able to hear me? Ajay? Yes. Hi Akash and Ajay, Nand Kumar, are you able to hear me? Hello?
Muted. Unmuted.
Hello. I think the chats are not refreshing and I can't hear anybody. All right. All right. So, okay. So I can see one question from Ajay. What is the mechanism used in yarn for jailing a process? Let me note it down. Is there anybody else able to see the questions? Because I'm not able to see your responses. Wow. Finally, I'm able to see your answers. Okay. Okay. Looks like the network is now working. Ouch. This was bad. So there are quite a few questions. All right. Let me try to answer them one by one. Okay. So for me, all three of the networks look like they're coming from the same source. Okay. So sometimes the replication factor of three. Okay. Sometimes the replication factor of three does not help. Okay. So I have three network connections. Still, it does break. All right. All right. So looks like now it's fine. Let me try to explain again. All right. Extremely sorry for all these disconnectivities. It's quite frustrating. Okay. So this I have covered, I believe. Can you give an example of non-MapReduce computation? All the Spark and Thales and HBase and streaming examples of Storm are the non-MapReduce computation. Now, can the node manager be on yes? What is the mechanism used in? Very good question. All right, this is a very important question. So let me try to explain what does it mean. So what is the mechanism used by yarn for jailing a process? What does it mean? When you try to execute something in yarn, it has to remain in certain boundary, and that boundary is enforced by the virtual machine by a way of something called class loader. Okay, something called class loader. Okay, so the virtual machine of Java. Okay, so the way a web server runs many applications in parallel, isolating their memory, isolating their access patterns. In the same way, a yarn runs many containers parallelly. Okay, that's a good question. Next question is, what is a container? Container is the minimal unit of execution. Container is essentially a process, a Java virtual machine running on the node. It's basically a process in the Java virtual machine, and it basically runs your code inside it. Okay, so your code, whether it in MapReduce, whether it's in Spark, whether it's in HBase, or any of those yarn applications, everything at the end of day runs in the container. Okay, all right, all right. Let me go through the beginning. Okay, I think you will understand it. Okay, so we took an analogy here. Okay, and I'll take this and put it here. And okay, so we say, okay, all right. So when we talked about this part, so question from Samip is why it seems like yarn as a replacement of MapReduce. So yarn is actually refactoring of MapReduce 1.0. Okay, so you can, if I have to write it this way, I'll say MapReduce 1.0 became became yarn plus MapReduce 2.0. Okay. Now, similar to MapReduce, the good part was many other applications also came into play. Perfect. Good questions. Now, moving ahead. Next is, let's try to understand this diagram. So we talked about in a network, we install node manager on almost every node because node manager is the one responsible for execution of work on every computer or every node. We will be using node and the computer interchangeably. All right. Okay. Recording is being done. Okay. And then resource manager is only single. Okay. So you as a client always your first touch point is the resource manager. All right. So if this whole thing is a country, if this whole ecosystem or your cluster is a country, okay, and this guy would be the prime minister of this country, and this will be a state. It's in state. It's a state. Say uh, state of a country, then this guy is going to be the chief minister of this country. Okay, so basically, uh, this chief minister is responsible for the state while PM is responsible for the country. And if you have this kind of ecosystem, so there are many chief ministers and many states in the country, in this country. So what's exactly happening and why we call yarn as another resource negotiator? Let's see. So a client, a user comes to the resource manager. Resource manager asks the client that, hey, what is it that you need? Client says that I need to execute this process near this data, and I need three processors, and this file need to be processed. Now, resource manager talks to all the node managers and tell them that there is a client that has come in, and that client needs this much resource right now. Okay, and since resource manager node knows all the node managers, it basically can allocate the various resources on the cluster. So for every client, it creates something called application master. For every application, if there is a MapReduce client that has come in, it'll create MapReduce application master. Okay, what does it mean? It means it's like creating a head office. Okay, if Microsoft is a client and India is the country, then so Microsoft goes to the prime minister and says, hey, we need to have Microsoft's office in India. So the PM says yes, and where do you so what kind of office do you want? And then it talks to the chief ministers and hand over the work to them, and first thing the client does is establish their head office called application master. Now afterward, application master would be responsible for getting the work done via resource manager and node manager. Okay, so you can see that here. So there are different kind of industries or companies, client that could come in and they can ask prime minister that, hey, we need this, which state will be free for this? Then PM will talk to CMs and then say that this particular client need this much resource, can you provide in your state? And once this node manager or the chief minister of the state agrees, they create a container. So application master itself runs inside a container. And afterwards, once application master has been established in one of the states, this application master will further talk to resource manager and request for more containers and request for more resources as and when it needs more resources. And then this application master has all the logic that the application master knows how to get its work done. Application master contains the MapReduce logic internally. Similarly, HBase application master will contain everything related to HBase application. Similarly, a Spark application master would know everything that needs to be done in Spark. Now, the most important thing that we need to understand at this point is that we do not need to pre-install we do not need to pre-install new systems in Yarn. So the way we thought that, okay, if we want something to be done via Hadoop, we need to install MapReduce clients or Node Manager and Task Manager. But in case, let's say you have installed a Hadoop 2.0 and you're pretty happy with MapReduce, but tomorrow a team comes in and says, we need Spark as well, not only MapReduce, then you don't need to install Spark on all the nodes. As you submit the job to Yarn, Spark automatically creates its application master, and this application master is what contains everything related to Spark. Okay, Do I make a sense? Ankit's question is, who is accountable and who is responsible for the task? Okay, so I'll come back to that. You will get the answer. Akash's question is, can there be one resource manager like in the case of two name nodes? No, actually. Generally, there is only a resource manager, and resource manager does not have a backup so far. Ajay's question is application master's logic something developer has to provide? So the developer of that application. So Spark guys would provide you one Spark guys would provide you one jar that you need to send along with your code to the resource manager. That jar would be basically the application master, and afterwards that jar is a package of the code. Okay, so the application developer says Spark has provided a jar which runs on Yarn, and you submit that jar along with your code to resource manager, and then it will get the work done. All right. Akshata's question is, how are the other processes handled by MapReduce? Okay, how are the other processes handled by jar referring to processes other than MapReduce? Yes. So when a client submits any work to resource manager, it submits the logic of application master, or you can say that it submits a program the way you provided with a binary when you execute something on the Unix program. Similarly, the client will hand over a binary to resource manager saying this is my application master, and it submits the application master. Yes, that's correct, Ajay. So each application which uses Spark, let's say, has to provide this jar file. Yes. Ajay's question is, why is that application master not part of the infrastructure? The reason is, uh, since the day, let me take again, since I had said that we are going to talk a little bit politics. So since the day the country has started to become make things privatized, things have improved far better. Same philosophy was behind Yan, that hey, we are not going to get into the details of execution of everything. We will just be kind of a government. We will just be providing the infrastructure and providing the resources and making sure that you do not cross the boundaries, and getting something done is your responsibility. Okay, so that's the role Yan has played. So imagine that Spark was installed on the cluster. Every time a new version of Spark comes in, we have to upgrade the cluster, right? And secondly, the moment we say that only those things which are part of the infrastructure can be run, that means if you install Hadoop when Spark was not there, and today Spark has come in, you won't be able to run it on the cluster. Okay, because changing the infrastructure, upgrading the infrastructure is quite a cumbersome task. Do I make sense to you, Ajay? A question is, if you want to run multiple applications using Spark, there would be multiple instances of jar. Yes. So, that's how we are going to discuss. That's a very important point you have raised, Ajay. So there is something called long running process. So the process is, if you want to keep running for quite long, you can run it so that there are not many instances. We'll talk about it. That's a very important point. Okay, so everybody clear till this point? So a client asks resource manager that, hey, I want to run my program, but resource manager says that you can get anything done as long as you are running inside the container, and I'm going to create your first instance of application master here, and then application master can take a decision on many things. Okay, so application master, so further, a client asked resource manager essentially to execute application master, and once application master starts running, it starts asking for more and more containers to run. All right. Let us say you are submitting map reduce job to the resource manager. So first thing the yarn will do for you is it will start map reduce application master, and this map reduce application master would know what to do with the map reduce jobs which you have submitted along with the map reduce jar, and this jar would contain. So your logic would be executed by the application master by requesting more and more containers. It's exactly the model of industrialization whereby the work is done by a firm from outside, okay, or inside. So every firm has to go through this ecosystem. Okay, so when the important part is the first thing PM does, first thing which is done as part of this ecosystem is establishing the head office of a company or a task so that the work gets started and then the chain starts from there. So application master is the one which is going to decide how many container does it need, what work needs to be done, and so on. Okay, and why, you may ask, why do we need, why can't this application master's job be done by client? Because let's say you come up with a question that the work that's being done by application master, meaning application master is going to create more containers and get the work done, why couldn't that work be done by client? Client asks for resource manager, says that these are the containers, please get it done. Why? The reason is the connection between client and resource manager could be flaky, meaning if it's in the midway, that could drop. But keeping that aside, the other challenge is that if client starts doing the work of application master, client's memory, client's ability may not be good enough. Maybe application master needs more memory, more CPU cycles, which client itself does not have. Okay, so those are the very good questions. So Pawan's question is, so input splits data locality logic will be done by MapReduce application master. Yes. So data locality logic is something done by Yarn. While asking for containers, while this head office asks resource manager for containers, it could say that can you give me the containers which are near to this data? And then resource manager will tell you that these are the containers which are nearer to the data. Okay, we'll go into the logic of input splits as we go forward, but most of the work is done in conjunction this way. Okay, do I make sense? Anil's question is, where does communication with name node fall in this diagram? So communication is done by the resource manager. So client ask resource manager that, hey, can you create my application master near to this data? So client comes up with a request and resource manager talks to individual machine. So client comes to the resource manager asking for a container near to a certain data. Okay, and this finding near to the certain data is the duty of resource manager, and hence the data locality part, meaning the communication with name node, finding which data node are containing a particular file, is the duty of resource manager. And then once resource manager finds that out, it creates those containers nearer to the data. Okay, do I make sense? Is everybody with me? So Pawan's question is, but application master need not have any data locality. Yes, but sometimes it could, right? So every request that goes to resource manager can specify whether you are looking for the container closer to the data, okay, or not. Those are called locality constraints. We will see it immediately in the next slide. All right, a quick recap. So you have resource manager, which is single in the whole cluster, and node managers on one on each machine. Node manager is responsible for a single computer, and the actual work is done inside the containers. All right, the work that which so the process is started by resource manager, and for every application application master is created, which takes the whole process further. Rol's question is, how does the resource manager know which node manager has the required files that client has requested for? Very good question. So, what is a file when we talk about? We are going to talk about whenever we say file, which means HDFS data, data in HDFS. Okay, whenever we want to process a certain data, we push the data to HDFS, and from that point onwards, we start the processing. Now, when you ask resource manager that, can you give me the container which is near to the data? It's going to talk to name node, find out the metadata, find out the blocks, and then find out the data node that contain the blocks. Now, once resource manager knows where are those data nodes, it can always map the same IP addresses, same addresses of the computers to the node manager. So it can find out which computer contains data node that contain the blocks, and those computers, which node managers are running on those computers. So resource manager finds out which that's how resource manager finds out which node manager would be creating the containers. Make sense to you all? Okay, I hope I have not confused you. Is everybody with me so far on this? Yes, I'll try to explain this. Okay, so node manager is per node, okay, manages and enforces the resource allocations. Application master is per application, okay, for whether it's MapReduce, for MapReduce there will be one application master, and so on. It manages the application lifecycle. Okay, for example, in case of MapReduce, maps have to be executed on many containers, while reduce need to be executed on one container, that too once all the maps have finished their work. Okay, so that's a life cycle of MapReduce, and that's taken care, those complexities are taken care by application master. Okay, so this is a quick one. Here you can see that. So here application master is a MapReduce one. Here it's seeking. All right, let me also try to explain. Still not clear. Okay, let me explain this in the next slide. Is it not mandatory for each node manager to have a application master? Not really. Not really. Okay, good. All right, let me try to answer this. Okay, first I'll try to answer Nand Kumar's question. Pawan, I'll answer your question in the next slide, and that will create clear many things. Okay, Nand Kumar's question is that shouldn't each node manager have a app manager? Answer is no. Let's say your cluster is only having the people who are still using only MapReduce, not Spark, not Storm, not HBase, and nothing else. So, and there is only one person, one application being run in the system. Okay. All right. So, I'm trying to answer the question from Nand Kumar. And Ravichandran's question is where is data locality and what is it? Okay, I'll try. Data locality, what is locality logic? Let me explain quickly. Data locality logic means find out which node is closer to my data, which node manager is closer to my data. That's called data locality optimization. Okay, that's locality constraint, also we call them. We try to find out the nodes that contain my data so that we don't have to transfer this data over the network because network is costly and slow. All right. Next is, all right. I'll try to answer these questions. Don't worry. Okay. So again, back to Nandkumar's question. Is it not mandatory for each node manager to have a application manager? No. Imagine that you are churning, say, half terabyte data, half petabyte data, and you have, say, 3000 nodes. So there is only one process, but this process is churning huge data, and this data, if you divide half petabyte data, and half petabyte data is how many GBs? Half petabyte is 500 into 1024. This many GBs. So effectively, these many blocks. 1 GB has 8 blocks, so we have multiplied 500 into 1024 into 8. So which means 4 million blocks. If you have 3000 computers, so every computer is having close to 1365 blocks. And when you try to process this data, you need a lot of computation. So even though there is a single process running, but you need so many containers. Effectively, there is only one person using the cluster, therefore, there is only one application master. This is the master process which decides how many nodes are going to be consumed in a computation. Okay, so application master does not need to be on every node. It's not per node. Instead, it is per request or per process. Okay, good. Great set of questions. How are the slots divided between the nodes? Okay, it is based on what kind of computation are we doing, and accordingly, the work is distributed. All right. Now, Pawan, your question will remain pending for a little more while. So have little. Now, this another question. Let me see if we need to answer it now. If the application master is not the one which is launching containers on different nodes, how do we know where the application master is? Okay, yes, it does communicate back the address. Let me try to explain through different diagram. All right, so this diagram will make your question a little more clear. Client comes to resource manager. There are two clients. One, I think this is red color. Is this red color? The first one. And okay, so I'm partially colorblind, so excuse me for that. And second is the blue one. So this client comes to resource manager And then, okay, okay, so this client comes to the resource manager, and that's the first number. So client has submitted the request, or you can say the application. This application contains what kind of work is it, along with its application master's logic, along with what kind of resources the application master would need to run. Okay, so client has submitted the request, or you can say client has submitted the application, or application request. So if you see, application and request mean the same thing when we are applying for something. Okay, client has submitted the application. Resource manager launches the application master in one of the containers. Okay, because container is the smallest unit of execution, it's a jailed environment whereby you are not allowed to go beyond certain boundaries. All right, it's kind of jailed environment. Each container is a jailed environment, so application master runs inside the jailed environment just like any other logic. So resource manager creates a container on the node that's very much free, and based on the client's request, a client also indicates that, hey, my resource manager is very heavy and it would require at least this much memory. Now, once the application master has been launched, okay, then the next thing it would do is it would register itself with resource manager, and the client can talk to application master. It's kind of establishes a tunnel. Okay, so when you are running your MapReduce and you want to see the logs or real-time logs of the MapReduce which is being executed, you can do that. You can talk to the application master via this registration process. Okay, so application master has registered itself with RM so that a client when comes, it can directly be connected to the application master. Okay, because client might need to see the progress, it might need to send more logic, and so on and so forth. Okay, so a communication is established between the client and its application manager. Okay, you will see that when we are running a Spark application master, we continuously communicate. We are the client and we still communicate with the application master. It's not like you submitted the job and you forgot. Okay, now resource manager will start running the application master container, and application master, when it becomes alive, it becomes like a process from the code. Okay, so the code comes to the life, as in code which was basically stored file becomes the process. Then it starts asking for containers. It starts asking for the containers that, hey, I'm trying to run my process on these many computers. Could you give me these many more containers? Okay, so application master starts asking for containers, and then application master get the containers launched via node managers after asking the resource managers. Now, okay, and the application, the actual container, what's running in container, it also talks back to the application master, so that application master is in the continuous communication with its sub processes or the work. Okay, next is that the client talks to the application master continuously, and once it's done, Once the process has been completed, application master deregisters itself with resource manager and shuts down. When all the containers finish their work, application master will shut down. Okay, Ajay, does that answer your question? Great. Next, same thing can be viewed in this manner. Okay, so same thing can be viewed in this another manner. Client, that's you when you're submitting an application, talks to resource manager. Resource manager creates a container on the node. Every node manager is given an order by resource manager to create a node manager is asked by resource manager to create a container, and inside container there is an application process. This application process asks for resource manager for more containers, and the same thing keeps on happening. The way client requested resource manager to create the container for application master, similarly application master could ask resource manager to create the application further containers. Make sense to you? All right. Now the question from I missed that. Yeah, Pavan's question. When anybody asks resource manager to create a container or containers, they send a request to resource manager. When I say anybody, it could be the client or it could be the application master. It could be the head office or head office of Microsoft, which is say located in Hyderabad. It could be say a steel company or a Ford manufacturing company. So the first request for creating the company comes from outside, from a different country or from different ecosystem. And then once the head office is established, then this head office can ask the government to create more offices in different states or in the same states. It's the same way. It's the same way. So every time, whether it's the client or it's the application master sending a request to resource manager, the format is this. A resource request includes how many containers does it want? Okay, how much memory in each containers does it want, and how many CPUs in each container does it want? Third, are there any locality constraint? Meaning, are we saying that we are only looking for containers which are nearer to this particular data? When we are saying we need 3 containers and we say that this file should be closer to these containers. Other than these 3 4 parameters, we also can specify that we want it right away or we want it upfront. We can specify, either we want all of these containers right away or as we go forward. All right. So generally, we mention to the resource manager that we need 1 container right away, and rest will be based on the future system. Okay, so let applicate we in the first in case of MapReduce, the client will create only 1 container for the application master, and then application master, based on the file size and based on the file size, will decide how many containers it want, and then how many on the machines containing that file, right? So the locality constraint will be emphasized by the request. Okay, now next question is, what kind of lifespan a process has? As you must have seen in the computing, there are many kind of processes. One process, for example, let us say you start a terminal. So every terminal is a process. When we open a console, it's a process and it remains there, one per session. Correct? While When you run a command like ls, that command creates a process which dies immediately after performing works. It's not long running, correct? And there could be third kind of process which is running in the background and forever, one per customer. Okay, so one person can only be allowed for creating one process. So the lifespan could change very dramatically. Okay, lifespan could change very dramatically. Okay, and generally the lifespan of a process or a workload is in three categories. One, where an application is there per user's job. Okay, the simplest case is that we submit a job. As soon as it finishes, the workload disappears or the application master disappears. It's not a long running one. For example, in case of MapReduce, we submit a job, it gets finished, the process or application master dies down automatically as soon as the work is finished. Then there could be workload which is long running, and long running workload could be per user session. The way we have a console is a long running application. It keeps running, keeps reading the data from the user and keeps executing it unless the user disconnects or um, user uh, exits. Okay, so just the way we have console, the web console, we have a similar console for Spark, and that's one application per workflow. Okay, per workflow, and this is a long running process. It doesn't stop unless the client says that I'm exiting. Just the way console keeps waiting for your commands unless you exit from the console, the web console we are talking about. Okay, now there could be another long running application which are always on, such as the databases which are running in the background forever. So these are the three vague categories of the lifespan of various applications. Okay, these are the three vague kinds of lifespan, and Yarn supports all three of them. Okay, Ajay's question is essentially resource manager is not the only one which can ask node managers to start containers. No, actually, uh, you will always go through the resource manager. You will always go through the resource manager. Okay, let me just copy your questions. Is it clear, Ajay? Okay, so here if you see in the 4a, yes, let me see. So Ajay's question is that here the resource manager is trying, so resource manager, the container is being created by this. Actually, no. The first request goes to resource manager, and resource manager allocates resources, and then the next step is the container has been kind of allocated and it's basically executing the application inside the container. The allocation is still being done by the resource manager. Make sense to you? In the step number 3, before starting the container has been created with the help of resource manager on node manager, on the consensus of node manager. Do I make sense, Ajay and Ra? But that's a good point that you have mentioned. All right, there's some very these are very important and good questions. I hope everybody is on the same page. If not, okay. Let me, please ask the questions. Okay. Now, all right. Ajay's question is, okay, we have already answered this. Yes, Anuj, you can send me the questions tomorrow or day after. Yes, definitely. And all right. Next is that how client know how much containers is needed upfront. Okay. In most of the cases, the client will be some kind of a driver, or the application master would contain the logic whereby application master will examine. Let's say, let's talk concretely, let's talk about MapReduce. In MapReduce, it need to find out on how many machines does it need to run the logic. To do that, it basically tries to understand how much data are we trying to process, and for that data, how many nodes are there. Okay, so basically we could tell the resource manager that we need approximately these many containers, and it'll and near to this particular data. All right. And sometimes when you are executing, you will see as we go forward that in case of MapReduce, we can specify how many containers we need. For example, let's say we are importing data from MySQL into our servers, like into HDFS. Now, we know that our MySQL server is really powerful and can handle 100 requests per second. So we can say to our MapReduce job that, hey, can you create 100 parallel containers so that our maps are run parallelly upfront. Okay, so sometimes we know, sometimes we don't. In those cases, the frameworks such as MapReduce and Spark provide us the way to find out how many containers we need. Very good set of questions. Next is, does application master only do the job scheduling and coordination, or does run the actual process too? Okay, it does both the things. It does whatever it is required to get the work done. So, so it will run, app master will not generally run the map or reduce. Instead, it will schedule the maps and reduces to various machines. But the, the, the communication between maps and reduces is something managed by application master. All right. Now, Balwinder's question is, only name node knows which file is in which node. So yes, only name node knows. So everybody has to query name node to find the data locality. Yes, that's correct, Balvinder. So also sometimes client also gets it without talking to resource manager. Okay, so it happens both the ways. Sometimes your client or you need to know about your data, so you generally query the HDFS directly and then take a call. While sometimes you leave it up to the application master to get it done via name node, via resource manager. Okay, all right. Next question from Anil. If locality constraint is not specified, will the data be transferred between the nodes? Yes. If the application master has not been programmed correctly, let's say you created a nice, great new framework, but you did not take care of allocating the containers closer to the data, or you did not, while requesting for containers, your application master did not specify locality constraint, then these containers, when they read data, they will end up reading from the network. All right, everybody's questions answered. Did I miss anybody's questions? All right, this is probably a very important topic and we cannot go faster on this. And my style is that the easier topics I'll go a little faster, and these basic building blocks I will keep a slower pace. Okay. All right. Now, so this was the anatomy of request. Okay. This is how these are the various details on lifespan of the application and the resource request. Okay. Now a question from Pavan. Application master requests for containers in specific node, but it may get or not depending on the resource availability. That's correct. So generally, application master requests for containers, but it doesn't specify that I need on this particular IP address. Instead, it says that it'll be great if you give me the data, give me those containers which are closer to this particular file. Okay, that's the kind of request application master would send to resource manager. Okay, but resource manager might tell it back that hey, we could not find, we don't have those nodes which contain the data, which contain your data, but we have found a close by app. Ravichandran's question is, at what scenarios locality constraints not specify? RM will talk to name node to get locality constraint. So RM will talk to name node based on the locality constraint you have defined. If you do not specify the constraints, if you do not specify the constraint, then it will locate you the containers which are available on any node, right? It'll create the containers on any nodes which are free. Do I make sense, Ravichandran? Now, question is there an example in which you don't need to specify a locality constraint? As I gave you an example that you want to import data from MySQL to here. Now, you don't need to specify data locality constraint in this case because any machine can talk to MySQL and import the data, such as Scoop. While you import data using Scoop, is going to create MapReduce, but maps will be on any machines. There will be no locality constraints because it does not, this process of importing data has to read data from SQL, not from the file system. Therefore, it doesn't need to create the locality constraint. A question from Ajay. If RM is the one which is allocating the containers, yes, then application master need not know about data locality constraint. Okay, so RM is the one who is allocating containers, but whether to apply locality constraints or not is the decision taken by the application master. All right, whether to apply, whether to get the nodes nearer to the data or not is the duty of resource manager. Sorry, it's the duty of the application master or anybody requesting the containers has to specify the data locality constraints. Okay, while the data locality constraint will be in the form of can you give me the containers which are closer to this data, while the allocation has to be based on the IP address of the data node containing the files or containing the blocks of the file which we are requesting for. Good. Great set of questions. Anil's question is, in which container does the reduce computation happen? Okay, very good point. And I think we'll uh, let me jump up further a bit. If you do not understand MapReduce, don't worry. We are going to go into really good details. So don't worry. Anil's question is, in which container does the reduce computation happen? It can happen on any container because the reduce part does not need to be on one machine, because in reduce the data from all the nodes on which the mapping has happened, map function has been executed, the data from all those nodes goes to the reduce. Therefore, reduce does not need to be on any of the nodes. Therefore, while requesting a container for executing reduce, application master will not put the locality constraint in the request. Great, brilliant set of questions. Moving ahead. Now, let us say you want to build a product. You came up with an idea that my my application is far better than MapReduce or Spark or anything. Or you have a specific kind of MapReduce. Okay, you have come up with your own design. Then in those cases, how would you build your application? My quick answer is that you should first try to use MapReduce, Spark, Storm, or say HBase. Okay, mostly your need would be fulfilled by any of these frameworks. Second, if that doesn't fulfill your need and you need to really build something custom, try using Apache Slider. Apache Slider can run any application as distributed in the on the yarn cluster. Okay, or you can use using Apache Twill. Apache Twill is basically a way of executing a Java process on the yarn cluster. Okay, otherwise, if it is still you're not happy with Apache Slider, Twill, or MapReduce or Spark, you can build the yarn application. But building from the scratch is little complex. But luckily, there is a sample project in yarn's examples called distributed shell application, a distributed console. You can use that distributed application as the starting point of your application. So even though it might sound that creating a yarn application is complex, but if you have this example, it'll help you. All right. So I'm not going to go into the detail of how to build yarn application. Like if you want to build a competitor to Storm, Spark, or MapReduce, you can do that. That's the beauty of being in open source world, that everybody can do the change. For example, the person who wrote Hadoop 2.0 was not from the was basically not the co-founder or founder or somebody who belonged to Cloudera. He was an external person named Arun Murthy and all. All right. Next is okay. So we have talked about Ambari Hue. We have talked to the SSH make directory copy to HDFS, and MapReduce command we will not execute now. We'll execute later. Okay. Question from Anil is that is there any fault tolerant in Yarn? Mm, in Yarn, the problem right now, the if Yarn, I mean, the resource manager shuts down, then there'll be a problem. But if node manager shuts down, there's not much of a problem. Same thing can be executed on other nodes. Okay. So if, let's say, one node manager goes down, heartbeat is lost from that particular node manager, and resource manager will basically try to move the containers to some other node. Okay, that's the kind of fault tolerance we have at resource manager level in Yarn. Okay, all right. Okay, these things we have already discussed. All right, we will now start discussing and try to understand the MapReduce. Okay, till then, let's take a break for 10 minutes. Back by 9:54 p.m. IST. Right, so I'm back. Should we start now? All right. All right. Great. So before the break, so far we have discussed few things. Understanding that whatever we are going to discuss in these classes is going to do computation, storage, and everything related to big data, meaning distributed computing. Then we talked about how data is stored in HDFS in a distributed way. Then how does the computation used to happen in MapReduce 1.0? And then how does the computation happened in the yarn? How the process execution happened in the yarn? Now we are going to try to use one of the frameworks called MapReduce, which run on top of yarn. And then we will discuss other things which run on top of MapReduce, such as Hive, Pig, Scoop, Oozy, and others. All right. And then we are going to discuss Spark and one thing called Spark Streaming that runs on top of Spark. Okay. So you can see if I have to draw the same thing as a diagram, this is what I'm going to do. Okay. All right. Let me just discard it and create a fresh one. All right. So basically, this is what we are talking about. This is yarn. Okay. And on top of yarn, we are going to discuss the MapReduce, and we are going to discuss the Spark, and then applications on top of Spark, such as Pig, Hive, Scoop, Oozy, etc. Okay, and then we'll understand and talk to Spark directly via PySpark. Okay, we'll PySpark, and then we will discuss something called Spark streaming. Okay, this is going to be the general flow. All right, so we'll go step by step. So far, and we have already discussed the storage part. This is storage. Okay, storage in done in HDFS. Even for Spark, the storage is HDFS. Even for Yarn, the storage is HDFS. All right. So that's the kind of way we are going to handle big data. Good. Now let's get into the real work. So Yarn, when we talked about Yarn, we talked politics. We did not talk about exact work. What is it that's going to go inside container or inside application master? We have not discussed that about anything. So we are going to discuss MapReduce, and then first the why we need MapReduce, and then we will discuss what goes in application master and how does the process run and how can we create MapReduce application with or without Java. All right, great. Now, so this is going to be the flow. All right. So here is the question for you. And can I bring all to the front? No. Okay. For some reason, yesterday when we did this, Mhm. can't make it full screen. Or can I make a full screen? Right, this is good. This looks good. Alright, it's a little clumsy, but that's okay. Okay, so I'm going to ask a few questions to all of you. The first question is, let's say your boss asks you to compute the frequencies of the words in some huge data. What are you going to do? How are you going to solve this problem? One fine day, you assigned a work that there are these text files containing, say, the data equivalent of Lord of the Rings books. How would you find frequencies of the words? What do you mean by frequencies of the word? All the unique words and how many times each of those unique words have occurred in this file. That's what we want to find out. So we want to find out all the unique words and how many times each unique word has occurred in in this data. Okay? How are you going to do this? Anybody? Yes? Anil says, break down the words and count the occurrences. Okay. Okay. Pawan says that we write the logic in Java. Okay. And we can count the frequencies using hash map. Good. Good. Josephine says sort them by common or duplicate. Okay. That's good. That's good. Sort them by common or duplicate. Pawan says or any other language for that matter in the same way. Alright, I'll explain these answers in a minute. Akash says using a dictionary. Good. Dictionary as in a dictionary data structure, right? The hash map, hash table, or dictionary object. Yes, yes, that's good, Akash. Brilliant. Balvinder says stream through chunks in parallel if it's a new word, then add else, increase count. In the end, combine the results from node. Well, that's very nice, Balvinder. We are going to now. In your question, my counter question to you is that if we are streaming through the chunks in parallel, how are you going to find out that if it's a new word or not? Because the same word could occur parallelly on another node, but I'm assuming that while combining the results, you will do the deduplication again, right? This is good. Your answer is good. All right, but you're just few steps ahead of us. All right, we'll go there eventually. All right. Anybody else? And we will also try to understand what are the faults in this approach. Okay, good. Great. Any other approaches you can think of? Everyone? No? Ajay, Akshata, Ankit, Anuj. Narottam, Uvang, Patrick. So is the question clear to everyone? Pavan, Raul, Ravichandran, Ravindra, Robert? Yes. So what would be your approach to solve this kind of problem? This is probably most simplistic problem. Okay, when we are into analytics or into computing, these kind of challenges will be you will be facing every day. All right, here the challenge is very simple. Find the unique word and their frequencies, as in how many times each of these unique words have occurred in the text. Start parsing, and each word encounter keep the value as 1 and otherwise increase. Okay, good, good. All right, brilliant set of answers. Okay, yes, Ajay, that we will go there, we will go eventually. Right now, I'm assuming that you do not know MapReduce. Now, the question to you, Ajay, is that if we have just say 50 MB of data, do you need MapReduce? We'll go eventually there. All right, great. Great, that's correct. All right. So the common approach which all of us have come up with this, it's a programmatic way of doing the counting of the words. The approach number one is create a frequency table or a hash table. Sometimes we call it a dictionary. Okay. It's basically just like your dictionary, empty dictionary you can say, where there'll be word and their meanings. Meaning in our case is counts instead of meaning, and key is the word is the actual word which we find here. So for each word in the file we insert it in dictionary. If it's not there already, we insert a fresh one. Otherwise we increase the count of the existing word, and this is a good solution. But do you see any problems with this approach? Will this approach lead to any problems if the data increases? Okay. Do you see there are some challenges in this when the data increases? Pawan says if the data structure becomes big data, it may not scale. Yes. Anu says time. Yes. That's correct. That's very much correct. So yes. The problem is that this cannot process the data with beyond RAM size. This is great, this will be fast, but this cannot process the data which does not fit into the memory. And this is the first instance which you will face. This is a similar kind of problem that you will face when you do the computing using in-memory application like R. If you try to churn data which is beyond the size of RAM, there'll be memory overflows. Okay. Also keep in mind that if your data is of 1 MB size and you try to create a dictionary out of it in a language like Python or C Sharp or Java, the memory consumed for 1 MB data in the data structure like dictionary or hash table is around 4 times. So dictionary is around 4 times the actual size of the data. Therefore, there are limitations to this approach. Yes, that's correct, Ajay. If the size of the dictionary exceeds the memory, then this approach is not valid. So, do you see any other any solutions to this? Yes, that's correct. Data size can be more, and that cannot fit into the memory. I have heard about, say, 100 gigabyte of RAM, which means it can't process the data beyond 24 gigabytes. All right. Yes, that's the right approach, Anuj. So we are going to discuss how do we divide and conquer. Brilliant. Good. Good. Now, the approach number two is using SQL. Okay, the approach number two is using SQL. And this is a common approach. And so if I have been given this data in plain text file, I'll import it into my SQL such that one line is a single row, and then I break down the line, and then using SQL I will convert every line into one word per row. All right. So we could say select word comma count star from a table, group by the word. Okay. This approach does not have a limitation on the memory because every database tackles the memory properly. Okay, is everybody clear with this approach? Yes. All I'm trying to say is the second approach could have been using a database. And database makes sure that memory is consumed appropriately, not like exhaustively. Good. Now the third approach could be Unix. Okay. All right. Is this okay? In Unix, let me try to show you each of this command, and that will probably make your life easier. Alright, let me try to explain each section of this file. So, in other words, we could use a Unix process to do the same thing as done by approach 1 and 2. Okay, and what is exactly are we doing here? Let me try to explain, because we are going to use the similar way for our MapReduce ones. Okay, so in Unix, you can execute a command like this. So this is an individual command. It says cat file. Cat is the name of the program, okay, which will be searched through the path environment variable, and wherever it's found, it will be loaded into the memory and executed, right? And then this is the argument called my file. So what does cat command do? This cat program command, or whatever process, what does it do? It essentially reads its first argument, opens that file, and starts printing whatever is there inside the file onto the screen. Cat basically prints the data from the file to your screen, not to the printer but to your screen. Okay, now that's the command. Now what is this? This is also another command here, and this is also another command. What exactly is this? This is a character just above the enter keyboard, on just above enter key on your keyboard, right? This is a pipe character. It's a vertical line. What does it do in Unix? It basically sends the output of that process on the left as the input to the right. Correct? So every process, when it runs, it can accept the input from you. You can type in the input, and that input will be read by the process. Okay? So that input could, instead of coming from you, could come from another process's output. Okay, so this is called piping in Unix. Okay, so it's based on the idea of inter-process communication, where one process prints the data to another process which consumes the data. So here, the output of cat is being consumed by SED. Okay, now what does SED do? SED substitute one character or a regular expression with another. Okay, so right now let's just understand this particular syntax. It says substitute tab or spaces or multiple of those things. Plus means multiple of those things with a new line. So this is called a regular expression. Regular expression is kind of a pattern saying whatever, how many ever you see spaces, replace it with a new line. That's what it means. So here we are saying replace white space with new line, which means convert one line per row into one word per row. Okay, convert lines into words. Perfect. So SED will consume the data printed by cat and take each line and replace tabs and spaces with new line. Now, the output of SED is being sent to another command called sort. What does sort do? Sort basically takes any input data and orders the lines in the input data by ascending order. Okay, if you want to change the behavior of sort, you could specify in the argument. Okay, and what is it that we have specified here? We have specified sort minus as 1G, meaning use only 1 gigabyte of RAM. Sort command, this is a very interesting program in Unix and is very powerful. You could use it for many use cases. So without writing code, you are able to do many complex things by, by pipelining various commands of Unix. So the output of cat command went to SED, which replaced the spaces with the new line. Then sorted that data, those words, by keeping the memory consumption up to only 1 gigabyte. And how does the sort do that? It basically splits the input data into 1 gigabytes, and then once it has broken down the file into 1 gigabyte chunks, it orders individually and then merges those together. And the output of sort is handed over to unique. Unique basically find the unique frequencies in the input words. Okay, so unique demands that the input data sent to unique should be ordered. Okay, so unique demands that the data which is input to unique should be ordered. Is everybody with me? All right, is it clear this pipeline, or is it still looks like a complex thing? And everybody, great, great. All right, I'm really happy that I was able to explain it, because that actually summarizes most of the Unix system. Okay, there are many similar commands which can be pipelined, such as WC and many more, which can be pipelined to give great results. Okay, if you want to know a little bit more, you can go through any of the Unix books. And if you want my suggestions, I can give you a couple of references. Okay, so here we go. So essentially, this command will compute the unique words. I would like to demonstrate to you. If you are comfortable, let me open the console. Or let me just open CloudX Lab. That should give me that should give me my lab details. Okay, so it has been copied and I'm opening in the console. Okay, let me open that. Alright, it's now good. Great. Now this is good. Next is let me just show you a file which we'll be using. It's called big.txt. Okay, let's do a nano on that file so that we have idea about what's there in this file. So this is basically the ebooks concatenated together from Sherlock Holmes, the Adventures of Sherlock Holmes by Arthur Conan Doyle. Now, we could say Nano is a text editor like Notepad. Alright, now let me try to do the command. So it says that big.txt is not there. Alright, I think I've not typed it correctly. Alright, now instead of seeing the whole data together, I'll just put more. More will give us the data one page at a time. The output of unique minus C goes to more. Okay, let me just go through the command again here. So cat, the output of cat goes to SED, SED goes to sort, sort goes to unique, and unique's output goes into more. All right. So you can see that it has counted this one. The only problem I see is that these characters are not properly sanitized. Okay. If I have to sort the output of unique, I could do that quickly by saying sort again and minus n. What does minus n do? It'll again sort the data numerically, meaning because in the first column this is the number of occurrences of every word. Okay. If I say minus nr, that means it'll order it in the reverse. Okay, so you can see that the word has occurred 71,000 times. Okay, off has occurred 39,000 times and and has occurred 35,000 times. Make sense to you? All right. So that's about it. All right. Is it clear to everyone? So we talked about two approaches. One was with SQL, other was with Unix. In both these approaches, problem related to the memory was eliminated. Problem related to the memory consumption was eliminated. In case of SQL, SQL takes care of internally the grouping and everything. Basically, SQL uses the similar technique what we used in Unix command, unique command. So this big file is quite small actually. This big file is quite small. So it's 6 MB file. Okay. All right. Now, so in case of Unix and SQL, we broke down the problem into sort rather than hash map. Hash map has an inherent problem that hash map needs to be in the memory. The problem with that approach is that it is going to overflow the memory. Instead, what we did was we converted our problem into sorting problem. Right? Remember how if we can convert our problem into a sorting problem, we can solve most of the problems. While hash table sounds great, but we can't distribute an hash table so easily. Now, when we converted it into our sorting problem, and there are many standard sorting algorithms available, therefore we were able to solve our problem very happily without making the memory the bottleneck. So Akash's question is, could you explain S and G in the regex? Sure. Here, S means substitute because SED can do other things than replacing one word with another. But we are going to use SED, this SED command only for substitution. Okay, there are many other things which SED can do. Therefore, we have used the switch called S in the beginning. Okay, and here we are saying G means do it for all words in the file. Do not stop on first occurrence in each line. Do it globally. All right, that's what G means. Now, question to all of you is question to all of you is do you see any problem with SQL and Unix approaches? This is a very important exercise, okay? And this is something which I found missing in most of the people who were working on data structures, map reduce, this and that in my previous organizations, even at the places like Amazon, these basics were missing. In case you want to go more detailed on various sorting techniques, I would recommend a book called Programming Pearls. Okay, if you are a little more enthusiastic about various techniques or algorithms and data structures related to this kind of techniques, you could go through a book called Programming Pulse. That's a very interesting book for data structure enthusiasts. Good. So Narottam is saying that the problem with this one is sequential run and no parallel computing. Yes. Pawan is saying quite time consuming if the data becomes big data. Okay, that's good. That's good. Any other? Anybody else? So in the first approach, the problem was very obvious. The problem was basically the memory consumption. While in second and third, we broke down converted our problem into a sorting problem, and we used a technique called disk-based sorting. In both SQL and Unix command, the sorting could be done on the disk. And we use that disk-based sorting to avoid memory becoming the bottleneck. Correct. All right. So the problem with the two approaches, SQL and Unix, is as the data starts growing beyond the memory, what would it do is the sort command will break down the data into smaller files, okay, that could fit into the memory. And then once you're done with that, it'll merge the individual sorted data, and then essentially combine the results. Now, it's a little confusing for lots of us, that how can it merge the sorted data, and why isn't the merge become the bottleneck? I'll explain to you this whole approach again. And before that, we need to understand it that first, sorting a huge data, say there is a 20 gigabyte file, and we are saying that sort command should not use more than 1 gigabyte. So it's going to break down 20 gigabyte file into 20 files, sort those 20 files separately, and then once it has done sorting all those 20 files together, it will start merging the results. And how will it merge the results? Since each 20 files are ordered, therefore ordering merged data merging the ordered data is very much easier. Merging the ordered data is very much easier. I will try to show you. Instead of talking about words, I will try to show you the I'll try to show you how data from various sources get merged. Okay, all right. Imagine that there are three files. Instead of talking about words, I'm going to talk about numbers. Let's say there were some files. Okay. All right. Let me just put a marker here. All right. Good. Now, all right. Let's say this is file number one. This is file one, or you can say part one, part two. Perfect. After we have broken down, or sort command will break down a big file into small file. Let's say you got only two parts. And these two parts are sorted using memory individually. And let's say we got the results as 1, 2, 3, or let's say we got 3, 6, 7, 7. And in part 2, we again got 1, 2, 2, 3, and say 4, 4, and 5, 10, 14. Okay, now, okay, let's say this. So up to this, everything is clear. Let's say there was a big file, and sort command cut down that file into two parts, part 1 and part 2. Ordered the data in part 1 and part 2. Ordering, there are many techniques to order. You can use, it could use anything, but in memory. So using memory, it has sorted each of these two files separately. Now, let's say it wants to merge these files, correct? Let's say it wants to merge. All it has to do is open both the files, read from the beginning. If both are equal, then pick both of them. Pick both of them. Okay. We are sorting in the file. Then again, if both are equal from both the sides, it will pick the data from both the sides together. Okay. So till now, both the files are moving parallelly, right? Now, the moment if you'll again compare the beginning of part 1 and part 2, whosoever is the smaller, it takes it out and puts it in the output. Again, part 2 is still smaller than part 1. and then part 1 is now smaller than part 2. Compared to 10, 6 is smaller, so it will pick 6. Put it here, and then 7 goes in the output, then 9 goes in the output. This is how merging of sorted data happens. Now, what we noticed just now is that to merge the data from two parts which are already ordered, it's not too big a task. All you have to do is scan the two files parallelly only once from left to right or top to bottom. Did I make sense? This is called merging, and you must have read it if you have read an algorithm called merge sort. Yes? Did I make sense to you? All right. Because I'm talking about this because we are going to discuss it when we talk about reduce phase of map. Okay? So what we did just now is basically broke down a big file into small portions so that memory doesn't become a memory hog. It doesn't become a memory hog, and then individually sorted the data, then merged the data, and then counted the data. Counting in ordered fashion is not a big deal. Okay, counting in ordered data is very simple. You start from here as long as the data is same. You keep moving and increase the counter, and hence 1 has occurred twice, 2 has occurred how many times? 2 has occurred thrice, 2 has occurred thrice, good. Then 3 has occurred twice, 3 has occurred twice. Then 4 has occurred twice, 5, 6, 7 all have occurred. This is occurred 1, 1, 2. So simple to count the sorted data. So grouping the sorted data is very straightforward, and so is the counting of everything. Make sense to you? So this is how we count the ordered data. So we are able to compute the frequency visually. All right? The strategy is simple. The code might look complex. All right? So that was our way of merging data. All right? Now, when all of this magic happens inside that Unix command or inside that MySQL, there are few things that become bottleneck. First, sorting huge data many times might consume a lot of CPU. Second, the disk speed at which you're reading the disk, because disk reading and writing both are going to play a role because you're going to read and write individual parts of the data, and that's going to take quite much time. Second, it might consume more disk space because the same file need to be split into many files and kept copies of the same file in a temporary location, meaning whatever is your file is going to duplicate it for the purpose of this. Although the temporary data could be deleted, but still is going to consume the disk space. All right. A question from Raul. How does memory overflow occur after merging? Because original and sorted merged file will be same. That's correct. So here whatever we did, whether merging or finding unique, did not need to be did not did not make it load into the memory. We can read from the disk and keep on printing to the disk. So we don't need to keep this data in the memory in order to compute the group by and other things. But the frequency table, the data set or dictionary need to be kept in the memory. Okay, is that your question, Rol? Okay, so in case we split the data into one gigabyte, it's not going to overflow. But if we try to do the dictionary for the whole data, it might it might overflow the memory. Okay, now how do you solve it further? Anybody? How do we solve it further? Now, some of you answered this question long back. I think Balvinder answered this one. If approach number 1, 2, and 3 did not suffice, in case the data starts growing big and big, the approach number 3 or 4 might hit the bottleneck of disk speed and the CPU. In those cases, we could use external sort. And how does this external sort function? It's a known data structure called an algorithm called external sort. It essentially, in this approach, we basically break down a file ourselves into smaller chunks, exactly the way we did in approach number 3 and 2. Just that, just that we send the work to multiple machines. Okay, so let's say you are on a machine on which you have the luxury of splitting data, and then you send some data to machine 1, some data to machine 2, and some data to some other machine. Each of these machines give you the sorted frequencies. Sorted, note down the word sorted here. Machine 1 gave you not only the frequencies, but the result is ordered by the key. It's like sorted hash table. Okay. Similarly, machine 2 also returned the launcher, the sorted frequencies. And then launcher will do the merging the way we have just described. And you will get the results in the following form. All right. So in the process of merging would happen exactly the way we did just now. We hold the two lists parallelly and compare the head of from the both lists, and whosoever is smaller we pick that and put it in the output, remove it and put it in the output, and keep on doing it for all the elements from both the lists. Now, do you see any problem with this kind of approach? Anybody? Do you see? So here in the approach number 4, we utilized many computers. We sent our file, one gigabyte file, to say 20 servers if we have 20 gigabyte file, and ask them to do the sorting and do the counting and give us back the results. So question to all of you is, do you see any problems in the approach number 4? Pavan is saying splitting the file equally with proper word boundaries is going to be a challenge. Good. And the coordination. Anil is saying network bandwidth will be bottleneck. That's good. Anything else? Yes. Sending data to the computation is not there. That's right. Yeah, sending the data to the computation. That's correct. That's what we are doing, and therefore we are going to make the network bandwidth bottleneck, as Anil said. Brilliant. Any other? Yes. Okay, that's correct. Rawl is saying that time taken to split the file will take time. That's correct. Any other? Akash, Ajay, Akshata, Anil, Ankit, Anuj, Balvinder, Josephine, Kanan, Narottam, Patrick, Uvang, Pavan, Rawl, Ravichandran, Ravindra, Robert, Samip. Okay, maybe the merging file will take time, but merging file just need to do read all the files in parallel fashion and then combine that from by comparing the heads of all the files. So merging will be taking time, but merging will be taking time. That's right. Yes, there are a lot of read write operations involved in file merging. That's good. Yes, brilliant. Fault tolerance need to be the responsibility of the application. Brilliant. Communication between the machines will be a problem. Correct. Any one device can also become the bottleneck. Great. Brilliant. Now I'm getting the answers. Awesome. All right. Yes. So So probably this is what you all said together. So one, a lot of time is consumed in transport of the data. Then for every requirement, we need special purpose network oriented program. For every requirement, you might have to stitch your own program. Second, would require a lot of engineering. Lot of engineering in the sense that what if one machine fails? What if, what if there are now, so some machines are busy and one has been successful? Should we distribute the workload again, or what should we do? Or we keep waiting forever? Or a lot of engineering means we have to stitch the file, split the file, and a lot of engineering would go into that. Therefore, okay, so on top of this approach, the next is MapReduce. The problem related to the transport is solved in MapReduce because MapReduce churns data from HDFS. So we send the code only to those machines which already have data. So the transport that happened in this approach would not happen because the data is already there on those node managers on which we are sending the code, on which we are sending our process to be executed. Correct? Second, we don't need to write code too much because ordering will be done by MapReduce, and we just have to use MapReduce correctly. All right? Is everybody with me till now? Great. All right. Now is the okay. So we'll just discuss a brief about what is MapReduce. So MapReduce is essentially a programming paradigm, and underneath MapReduce, it's a big sorting engine. We'll talk about it. Okay, it's great for solving sorting intensive jobs, or maybe the jobs which need a lot of data intensiveness, meaning we need to read lot of data, write lot of data. In those cases, MapReduce is great. So we just have to write two functions. One is map, other is reduce. Either we could write Java code in the form of mapper reducer, or we could supply command Unix commands or Python scripts or shell script or Perl scripts instead of writing Java code. So we have to provide a mapper and a reducer. Mapper would convert our input into key value, and the output of mapper will be ordered based on the key specified by the mapper. Mapper is your logic whose purpose is to take input data, convert the input data into key values, just like group by. What does group by do in case of SQL? What does group by do when we take a table and say group by on this table? We say that here is my key. Group this table based on a particular column. That's what the clause group by means. Similarly, in case of a map reduce, whatever key mapper provides, that is the basis for Hadoop to sort the output of the mappers. Okay, so you write mappers which converts input data into key values, and reducer takes the output of the mapper to aggregate the data. Okay, so what does so so you can imagine that mapper is a function which gets one line at a time from the file, and then mapper can convert that one line at a time into how many ever key values it wants. Okay, so your signature of mapper function, if you imagine a bit, should be look like this. Okay, I'll go into more details. Let me just complete the little bit of this general theory. So it's also supported by MongoDB, CouchDB, Cassandra. It's not only limited to Hadoop's MapReduce. Also, a similar paradigm is used in newer frameworks such as Apache Spark. It also Apache Spark also have map, flat map, reduce, and all other techniques. We'll go into those details as in the session number 9. And mappers and reducers in Hadoop can be written in Java, Shell, Python, or any binary. Okay, all right. I'm going to write some kind of a pseudocode. Okay, so a typical map would look like this. I'm writing a kind of a Java script code. Okay, or yeah, we are saying here is my mapper. It takes line is the input record, and it gives out, it emits key and value. Okay, that's the role of the mapper. It doesn't return anything. It basically calls a function called emit to give out key and value. So whatever logic you need to write here is up to you. It's completely up to you. Okay, so that's the definition of mapper. Then you would write a reducer which will take key and list of values, and then it'll basically emit certain value. Okay, okay. So this is kind of I'm trying to just say that, or you can say instead of emit here, it'll return a singular value or whatever. Okay. All right. Here key will be single. Here. Okay. All right. So what does it do here? This is the general signature of mapper and reducer, right? Let me try to write a pseudocode. Are these function definitions clear? So your role is to write your mapper and reducer this way. Function is the keyword that means that this is a piece of code which takes input in the argument and then emit the result using a emit function. Here, reducer takes this and return the value. Okay, so when we call to MapReduce framework would include the my mapper, will bundle my mapper and reducer input file to be processed. Okay, now let us say that we are trying to do the word count example. So for every line in the file, your mapper function is going to be called. So what do you do here is we are going to break down every line by space. So we're going to say for every word in line dot split, and we're going to say space or tab. Okay, we're going to, I'm just trying to write a pseudocode. This is a regular expression which says white space. And we are basically here, we are breaking down whatever argument we are given. Okay, and then we split it by space or tab. And then we say emit, emit word, and value could be anything. Value could be abracadabra. Okay, well, value could be, let's say, abracadabra. I'm just saying. Okay. Now, in here, reducer will get key, which will be the, okay, so in reducer, you will get the key and the list of values. So, walk through again. So mapper will be called on every line of your input data. And this mapper will result in many words along with their values. For, and what will Hadoop do in between is will take the output of your mappers, collect them together, sort it, and then group by the key. And for every group, your reducer will be called. For every unique word, your reducer will be called with all the list of the values. This will be gathered, all these values will be gathered for every word, and they'll go into the list. Okay, let's take a look at some of the examples. Let's say the input data is sa, re, sa, ga, and in the map, this line is being fed. If there are 10 lines, for each 10 line, the map method is going to be called. So for each word in the input, we are printing or emitting key and the value. So here we are using the word function called print instead of saying emit. So Ajay, we'll talk about combiner later. Okay, that's a reducer on every node. We'll talk about it. Okay, and so here it has given the mapper has given us the key and the value. This is my code. This is my code, and the result out of this goes through this dashed line. What does this dashed line means? It means Hadoop. Hadoop takes this data. Hadoop takes this data and groups these items by the key. Okay, it groups the data by the key. So GA, RE, and SA, and all the values are grouped together like this. And for every group, this reduce function is going to be called. Okay, is everybody with me? Let's imagine this for a time. Okay, let's say this was my input data. 2 lines. How many times the map function will get called? Anybody? If there are 2 lines? If there are 2 lines, how many times map function is going to be called? Yes, that's correct. Map function is going to be called twice. Now, when we ran a map, this was the result. 2 times the same function is going to be cloned or going to be called twice. If one line goes on one machine and this second line goes on another machine, then there'll be 2 machines running your piece of code. And see the beauty of it. You did not specify that your function, how should your function be run on multiple machine. Okay? But that would not impact the result. It'll be the same. So the result out of all the function calls of your map will be gathered and ordered, and once that's done, you'll get the key and the values. And for every such group, so Josephine, it'll be like 4 times the function will be called. This for each loop will print twice for every line. Okay? Does it make sense to you? Now, did I was I able to clear Josephine? All right. So for every group, my reduce function which works on group, what does it mean by group? Group contains the key and the array. So the second argument is this array and first argument is the key. So reduce function will be called how many times in this case? Anybody? That's right. Reduce function is going to be called 3 times. Ga, re, sa. Once the key will be ga, second times the key will be re, and sa will be another. The result of reduce will be basically counting the number of elements or summing up all the elements. It's the same thing in our case because all we're looking for counting the words. Okay. Is anybody else facing the voice problem except for Anuj? Okay. Thank you, Akshata. All right. How come call ended? Ouch. All right. So these are the functions that are there. All right. So basically you write map and reduce in a way to solve your problem. Map make sure the grouping happened correctly. So we'll go into the details of map reduce in the next session. But in the meantime, you could go through these problems in at the end of session. Okay, so if you go to session number 3, okay, we will discuss these subjective questions in detail. Okay, and you can start from question number 1. All right, you just go through these 5 problems and also go through the simple questions. So we will go into more details about MapReduce in the next session. All right. Probably it's 11 o'clock. That's why others whose call has ended, they are not able to join back. All right. So please go through these 5 questions. They are very important questions. Don't worry even if you don't get them, but it's important to understand them at least once. All right. We'll go into more examples and more details about MapReduce in the next week. Okay. A lot of concepts from distributed computing will be discussed in the next week. Okay, thank you, Akash. Samip, I'll upload the recording by tomorrow after tomorrow, say 11 a.m. Okay, so it'll take around 12 hours from now. All right, and okay, nothing else. So yeah, quiz and the 5 problems, and finish the hands-on exercises, please, along with the quiz of the first one. So there'll be a quiz on MapReduce, and we'll talk about it. All right, bye bye. Have a good day. Where is the hands-on? Take a look at session 1. Here, there will be installation instructions. Here, this one, Hue hands-on, you see? Okay, Samip, can you just drop me an email at Reachus? Let me see if any of my teammate can respond to you. Okay, we'll try to solve. Some of you have requested for one-on-one. I'll respond to them. All right, bye-bye. Have a great week ahead, and feel free to send a question. Have a good day. Bye bye. Thank you, Ankit.